The graphs of sine, cosine and tangent are periodic, which means they repeat themselves after a given interval. So if we first look at the sine graph, it repeats every 360 degrees, which is this. So when it gets to this point, it just repeats over again and continues to repeat. It crosses the x-axis at minus 180, 0, 180, 360, and so on, and has a maximum value of 1 and a minimum value of minus 1. The graph of cos is very similar, so it also repeats every 360 degrees, like so, and then repeats all over again. But it crosses the x-axis at minus 90, 90, 270, 450, and so on. And its maximum value is also 1, and its minimum value is minus 1. The graph of tan is completely different. However, it does repeat itself every 180 degrees. So this part of the graph repeats itself again every 180 degrees, and it just continues indefinitely. It crosses the x-axis at minus 80, 0, plus 180, 360, and so on. It doesn't have a minimum or maximum value, but it has asymptotes, so these vertical dotted lines are minus 90, 90, and 270, which are lines that the graph gets closer and closer to, but never touches. Firstly, we want to sketch the graph of sine in the interval minus 360 to 360. So if we draw our axis, our x is now theta, and y is still y. So like any other sketch, we need to label all the points where our curve crosses the axes. So sine crosses the x-axis at 0, 180, and 360 degrees, as well as minus 180 and minus 360. It has a maximum of 1 when x is 90 and a minimum of minus 1 at 270. It also has a minimum at minus 90 and a maximum at minus 270. So we can sketch on the curve now. And our graph looks like this. And don't forget to label a max of 1 and a minimum of minus 1. In the question, we're told that sine of 30 is equal to 0.5. So sine of 30 is roughly here, and our answer to that is 0.5. But if we look at our sine graph, sine of 30 is not the only answer that will give us 0.5. So if we draw a dotted line across at 0.5, it's clear to see that we will also get solutions at the points I've marked with an X. So here, here, and here will also give us an answer of 0.5. We can now use the symmetry of the graph to work out each of these solutions. So if we look at this first one here, using the symmetry of the graph about this line here, if this distance is 30 degrees, we also know that this distance here is 30 degrees. So to get our first solution, we would do 180 minus 30, which gives us 150 degrees. So we know that sine of 150 is equal to 0.5. We can now either use the symmetry of our graph again to find our other two solutions, or we can use the fact that our graph repeats every 360 degrees. So to get from this point to this point, which is 360 degrees earlier, we would subtract 360. So our second solution is 30 take away 360, which is equal to minus 330. So that tells us that sine of minus 330 is also equal to 0.5. Similarly, we can do the same for our other point here. So to get from this point to the same point 360 degrees before, which is this solution, we would do 150 minus 360, which gives us 200 minus 210 degrees. So we know that sine of minus 210 is also equal to 0.5. We're now asked to sketch the graph of cos theta in the interval minus 180 to 180. If we draw our axis, again we've got y and theta on our axis, and this time we're only interested in minus 180 to 180. We know that cos crosses the x-axis at minus 90 and plus 90, and it has a maximum of 1 when x is 0 and minus 1 when x is 180 and minus 180, which means we can sketch our graph. To look something like that. This time we're told that cos of 120, which is roughly here, gives us a solution of minus a half. And we can see that if we extend that line across, we get a second solution over here. So we can use the symmetry of the graph. So the graph of cos is symmetrical about the y-axis. So if this value of x is plus 120, this value of x is minus 120, which tells us that cos of minus 120 is equal to a half, using the symmetry of the graph. In this example, we're drawing the graph of tan, and again we're only interested between minus 360 and 0. If we label our axes y and theta, we know that the graph of tan has asymptotes at minus 90 and minus 270, and that it crosses the x-axis when x is 0, x is minus 180, and x is minus 360. And then we can draw on the graph of tan in the required region. We can now use our graph. So tan of minus 150, roughly here, and we're told that that gives us a solution. So minus 150 gives us a solution of root 3 over 3. So root 3 over 3, and if we extend that line across our graph, we can see that we get a second solution here. Now tan repeats every 180 degrees. So to get from this point on the graph to this point, we just subtract 180, which tells us our second solution is minus 150 take away 180, which gives us minus 330 degrees. So this means that tan of minus 330 is equal to root 3 over 3. So x is equal to minus 330. Now complete textbook exercise 9F, page 194, and do questions 1, 2, 3 and 4. Make sure that if you need help you see one of the maths teachers before your homework is due.